Hello and welcome to Chapter 2. Today we're going to talk about linear equations and inequalities. What is a linear equation? Well, I'm glad you asked. A linear equation is anything that can be written in the form ax plus b equals 0. Or more specifically, a linear equation in one variable, where x is our variable and a and b are constants. They're going to be numbers that were given. So for example, 5x plus 2 equals 0. That is a linear equation. Also, 3x minus 2 equals x plus 1. This is also a linear equation because we can rewrite it to fit this form. So let's first take a look at how to solve some basic linear equations, and we'll work our way up to this problem here. To solve linear equations, we first need to understand the addition property. Basically, if I say 2 equals 2, I know that this is true. If I were to add something to both sides of this equation, say I add 1 to both sides, that gives me 3 equals 3. And as long as I'm adding the same thing to both sides, I'll still get something true. Even though it doesn't say the same thing anymore, it is still true, and we can use this technique to help us solve linear equations. This also works for subtraction. If I had 5 equals 5, I can subtract 3 from both sides of the equation and I get 2 equals 2. It is still true. So if I have x plus 3 equals 2, I can subtract 3 from both sides to get x equals negative 1. And if I want to check this problem, I plug in negative 1 where I had x and then fill in the rest. Negative 1 plus 3 indeed is 2, and I have 2 equals 2, so this is true, which means x equals 1 is my solution. The goal with linear equations is to first get your like terms on their own. So for example, I have an x and a 3 here. These are not like terms, but 2 and 3 are both numbers. They are like terms. So I'm going to get rid of this 3 here by adding its opposite, or subtracting it from both sides. This then leaves me with just my variable term on one side and a number on the other, letting me know that x indeed is equal to 1. Next, let's check out the multiplication property. Say I have 5 equals 5. Well, if I multiply both sides of this equation by some number, say 2, I'll still get the same thing on both sides of the equation. Also, if I divide both sides of the equation by something, I still get something true. So I can multiply or divide both sides of the equation by the same thing, and my result will still be true. Let's go ahead and apply that to some linear equation. Let's say I have 4x equals 20, and I want to get x by itself. Well, the x term is already by itself, so now I need to get rid of the 4 to get just my x. I can divide both sides by 4 to cancel out that 4 over here, and now I'm left with x equals 5. If I want to check that answer, 4 times 5 indeed is 20. So x indeed was equal to 5. Let's try 4x minus 2 equals 14. If we want to solve this, we first need to get our x term on its own, so we're going to add 2 to both sides of the equation. This now leaves us with 4x, no more term over here, and 14 plus 2, 16. Now we can use the multiplication property, divide both sides by 4 by that coefficient in front of our x, and that leaves us with an answer of x equals 4. Let's now go ahead and try 3x minus 2 equals x plus 1. If I want to solve this, again, I need to get those like terms on the same side of the equation, so I can subtract the entire term from both sides, and now I can combine these like terms over on each side of the equal sign. 3x minus x, 2x. I have my minus 2 still, and that's equal to x minus x, which is 0, so there's nothing here, and my 1. Now I have this x term that I want to solve for, so I'm going to add 2 to both sides to get that x term by itself. So now I have 2x equals 3. I now divide both sides by 2 to get x by itself, and x equals 3 over 2. And that is my final answer. Let's now try 4 times x minus 3 plus x equals 0. There's some work to be done in this problem, since we first need to apply the distributive property. so that we can eventually combine these x terms that we have. So 4 times x gives me 4x, 4 times negative 3 is a negative 12, and then I add my x here, and that's equal to 0. I'll combine my like terms. 4x plus x gives me 5x, minus my 12 equals 0. I now need to add 12 to both sides, and I have 5x equals 12. I can divide both sides by 5, and I'm left with an answer of x equals 12/5. Let's say we have 2/3 x minus 1/6 equals x. Now we have some fractions in this problem. We can get rid of them by multiplying by the common denominator to both sides of the equal sign. Our common denominator for our fractions here is 6, so if I multiply the left side of this equation by 6 and the right side by 6, I will not have changed anything. I'm following my multiplication property, but I will get rid of these fractions. Here 6 times 2/3 x gives me 4x. 6 times a negative 1/6 is a negative 1. This is equal to 6 times x, or 6x. I now want to get my like terms together, but since they're on opposite sides of the equal sign, I need to move one of the terms over. So I subtract 4x from both sides. This leaves me with negative 1 is equal to 2x. I divide both sides by 2, and I have x equals a negative 1/2. Next, let's try 0.01x minus 0.42 is equal to negative 0.2x. We can get rid of the decimal points in a similar way we got rid of the fractions in the last problem. We first need to identify the smallest decimal that we have. Here we go to the hundredths place, here to the hundredths place, and here to the tenths place. Since the smallest place value is the hundredths place, we're going to multiply both sides of the equation by 100. If it only went to the tenths place, we'd multiply both sides by 10. So here, multiplying both sides by 100. I'll do that to the right side as well. So anything I do to one side, I have to do to the other. And I have here 100 times 0.01x is 1x, and minus 42 equals here negative 0.2 times 100 is a negative 20x. Now I'll solve this. I can get the x's together by subtracting x from both sides, and I have negative 42 equals a negative 21x. I now have x's all on one side, and it's the only term over here, so I can divide by that negative 21 to get x by itself, and I have 2 equals x. And that is my final answer. Let's take a look at what happens when solving this problem. If I have x equals x plus 1, I want to get the x's on the same side, so I subtract x from both sides. X minus x is 0, and that equals 0 plus 1, which is just 1. Now it says 0 equals 1. Well, that is not true. What this means is that this equation has no solution. Anytime all of your variables cancel out and you're left with something that is not true, you have no solution. Let's try 2x minus x plus 1 equals x minus 1. Here we see we have the distributive property again. We're just distributing a negative 1 here. So we have our 2x out front minus x minus 1, and that equals x minus 1. We can combine our like terms, which gives us x minus 1 equals x minus 1. I want the x's on the same side, so I subtract x from both sides, and I'm left with minus 1 equals minus 1. Well, this is true, but it did not give me any value for x. What this means is that I have infinitely many solutions. Since no matter what I plug in for x, I will always get something true. In this case, negative 1 equals negative 1. So regardless of the value of x, I will have a true equation, which means I can plug in anything for x, which means I have infinitely many solutions. Let's go ahead and solve this problem. 16 is 4 less than twice a number. What this is saying is that 16 is, or is equal to, anytime you see is, it usually refers to equal to, 4 less than twice a number. Well, if I have twice some number, if I don't know what that number is, I'll call it x. Twice that is 2 times that number. And then for less than that, I'm going to subtract 4 from it. And then I can solve now this equation for x. I want that x term by itself, so I add 4 to both sides. And I have 20 equals 2x. Divide by 2 to get my x by itself, and I have 10 equals x. So 16 is 4 less than twice 10. Next, let's solve this. The sum of 3 consecutive natural numbers is 81. Well, first, what are consecutive natural numbers? Natural numbers are our counting numbers. Consecutive means they come one right after another, like 1, 2, 3. Those are consecutive natural numbers. And the sum means I'm adding them all together. Now, I don't know what the natural numbers are, but I know what they're equal to. They are equal to 81. Now, if I'm adding 3 consecutive natural numbers and I don't know what they are, I can say the first one is x. Now, the next one, if I'm adding to it, has to be x plus 1, one more than x, which means the next one has to be one more than this, so x plus 2. So these are my 3 consecutive natural numbers. Now I can solve this to find out what that number is supposed to be. I have 3 like terms, x, x, and x, which gives me 3x, and then 1 plus 2, which gives me 3, and that is equal to 81. Now I can solve this here, subtract 3 from both sides, and I have 3x is equal to 78. Divide both sides by 3, and we have x is equal to 26. So what this means is that first natural number is 26, and the 2 after it are the ones consecutive to it, 27 and 28. So my 3 consecutive natural numbers are 26, 27, and 28. If I add those up, I get 81. Next, let's talk a little bit about percents. If I have 50%, percent means of 100. So 50% means I have 50 of 100 of something. So written as a fraction like this. Or also written as a decimal, it is 0.5. What we can see out of this is to convert any percent into a fraction, I simply need to put it over 100. If I have 2%, I can turn that into a fraction by putting it 2 over 100. As a decimal, all I need to do from the percent is move my decimal place from where it is at the right side of the number 2 places to the left. So that same 2%, if I move it 2 places to the left, that gives me 0.02. I can also go the opposite direction. If I have 0.35, that as a percent is 35%, or as a fraction, 35 over 100. If I'm giving my answer as a fraction, however, I want to reduce that. 50 over 100 reduces to 1/2. 2 over 100 reduces to 1/50th. And 35 over 100 reduces to 7/20. If I'm asking for the percent of something, like 30%, I want to multiply. So say I'm shopping and I see a sign for 30% off. Right? If the original price was $20, I can find how much it's off by multiplying 30% by that $20. But I'm not going to leave it as a percent. I want to always use the decimal or fraction form. So 0.3 times my 20 is going to give me 6, which means if I have 30% off of $20, I pay 20 minus 6, or $14 for that item. Now let's say tuition from 1 year went from $2,500 to $3,000, and you want to find out what percent increase this was. Well, we can calculate a percent change by finding the difference between the two amounts. We can find the difference by subtracting 3,000 minus 2,500, and always divide that by the original amount, 2,500. This is always equal to the percent change. This gives us 500 over 2,500. This is a fraction. In order to convert this to a percent, right, one easy way is to convert it first to a decimal, and then the decimal to a percent. So 500 divided by 2,500 is 0.2. Now 0.2 as a percent is, move that decimal place now 2 places to the right, and you get 20%. So if tuition went from $2,500 to $3,000, that was a 20% increase in tuition. Let's say you want to solve a motion problem like this. You're traveling 180 miles in 2.5 hours, and you want to know what is your average speed. To solve something like this, you first need to understand that distance is equal to the rate times time. This formula here, how far you travel is equal to how fast you're traveling for how long you're traveling. This formula can be arranged in a few different ways, either as d equals rt, or d over r equals t, or d over t equals r. Depending on what you want to solve for, it can let you know which formula you want to use. For example, here if I'm asking for my average speed, I want this last formula here, where my rate is equal to my distance divided by my time. So let's go ahead and give that a shot. That means my rate is equal to the distance I traveled, 180 miles, divided by how long I traveled, 2.5 hours, so 2.5 hours. So my rate then is 72, and that's miles per hour. In problems like this, you'll always be given one of those three pieces, either distance, rate, or time. You just plug in the two pieces that you're given and solve for the remaining variable. Now we just used the formula for distance equals rate times time, but here's some other formulas. P equals 2L plus 2W. Also, A is equal to L times W. These formulas are for a rectangle, where the rectangle has a length and a width. P here stands for the perimeter of this rectangle, and A stands for the area of this rectangle. Say the length of this is 5 inches, and the width is equal to 2 inches. If I want to find the perimeter, I just plug in those pieces, 2 times 5 plus 2 times 2, and that gives me P equals 10 plus 4, or 14, and my units are inches. For area, that's 5 times 2, and that gives me 10, and this is inches times inches, so I have now units of inches squared. For any formula you're given, for example, the formulas for a circle, C equals 2 pi r and A equals pi r squared. For these formulas, all you need to do is find out what each variable represents, and then you just plug those in to solve for the remaining piece. Pi here is a constant, which is about 3.14. R stands for the radius of the circle. It's the distance from the center to any point on the edge. Circumference here, C, right? That's your distance around the circle, and A is your area of the circle. So if I have a circle here with a radius of 2 inches, I can find the circumference now just by plugging in these numbers, and I can find the area as well, same way. So circumference equals 2 times pi times r. If I use 3.14 for pi, I'm going to get 12.56, and that's in units of inches. So the distance around the circle is 12.56 inches. My area is equal to pi times the radius squared, or pi times 2 squared. That area then is 12.56, and this is inches squared in here, so inches squared are my units. So I have a 12.56 square inch area for that circle. That's not all I can do with formulas. Just as you saw with distance equals rate times time, I rearranged it. Well, if, say, I wanted to find out what that formula was where r was by itself, I can find it by solving for r in this formula, just leaving the variables as they are. Rate times time, well, if I want rate by itself, I divide both sides by time, and I have distance over time is equal to my rate. Well, if I have a slightly more complicated formula, let's say C is equal to A plus B all over 2, and I want to solve this formula for B. I first need to get rid of this fraction, so I multiply both sides by 2. So 2C equals A plus B. and then I'm getting b by itself, so I'm going to subtract the a term from both sides. Now 2c and a, those are not like terms, so I cannot combine them. So just write it as 2c minus a, and that's equal to, here a minus a is nothing, so I'm just left with b. b equals 2c minus a. If we want a formula a little more fun, we can take ab minus bc equals ac, and we can solve this formula for b. Right, what we want to first get is all terms of b on the same side, which we have. Then, using our distributive property, now going backwards, we have that b in both terms. We can pull that out, and we're left with a minus c. So if we distributed that b here, we'd get back what we started with. Now this is equal to ac. Now if I want b by itself, I have b times something, so I can divide it from both sides, and I'll be left with just my b on its own. Here the quantity a minus c can cancel out with this quantity a minus c. I'm just left with b. Now I have ac, a times c over a minus c. So here I cannot cancel anything out. They have to be factors in order to cancel out, and c is not a factor of the denominator, and neither is a. a minus c as a whole is a factor. So I'm just left with ac over a minus c. So this is my final answer. Lastly, we're going to take a look at inequalities. These are the symbols for inequalities. Less than, greater than, less than or equal to, greater than or equal to. Having the little bar underneath gives us that or equal to option. So for example, if I have x is less than 2, that means x here can be anything less than 2. Not including 2, but anything less than that, like 1.999. X can equal that, but it cannot equal 2. If I put that or equal to option under there, then it can equal 2. It can equal 2, 1, 0, anything less than 2, including 2. Same with that greater than option. If I said y is greater than 3, that means y is anything greater than 3, so 3.001. Alright, anything greater than that, 4, 5, 6, so on and so forth. If I have that or equal to option under there, y then can equal 3, and anything above 3. If I want to solve inequalities, I first need to go back and relearn those addition and multiplication properties. 1 is less than 2. I can still use my addition property. So here 1 minus 1 is 0, less than 2 minus 1, 1. Right? I can subtract something or add something to both sides of this, and it will still remain true. 3 is still less than 4, 0 less than 1, 1 less than 2. So if I start with something true, I can add or subtract anything I want, and it will still remain true. So the addition property doesn't change. The multiplication property is a little different. So if I take, say, 3 is less than 9. If I multiply both sides by 2, right, this is still true. 6 is less than 18. If I were then to divide both sides by, say, a negative 3, 6 divided by a negative 3 is negative 2. 18 divided by negative 3 is a negative 6. Negative 2 is greater than negative 6. So this sign here that I've been using, the less than, is no longer true. I need to flip it. Alright, and the reason for that is anytime I multiply or divide by that negative number, I need to flip the sign. Let's go ahead and solve 3 plus 2x is less than or equal to 5 plus x. Here again, I just want to solve this using our addition and multiplication properties. Same steps as before, get your like terms together. So here, since they're on opposite sides of the inequality, I'm going to subtract x from both sides to get those terms together. I have 3 plus x is less than or equal to 5. I subtract 3 from both sides, and I have x is less than or equal to 2. Now you notice we have that negative here and there, right? Remember, only for the multiplication property, when I'm multiplying or dividing by a negative will my sign flip. Since I'm just subtracting, my sign stays the same all the way through. I have my answer here, x is less than or equal to 2, which means I can plug in 2 or anything less than 2 into the x's in this original problem, and it will be a solution to the equation. Let's take a look at how we can represent this answer in a few different ways. First of all, we can represent this answer on a number line. So x is less than or equal to 2. That means I can include 2 and anything less than 2. So I'm going to use a bracket opening in the direction less than 2, that bracket, to show that it can equal 2, and it will go to the left. And I can just use a little arrow here to show that it's going all the way to the left. So this represents my answer here, x is less than or equal to 2. What if though I had x is less than 2 without that or equal to sign? It's still less than 2, so I'm still going to start right here at 2, but I'm going to use a parenthesis to show that it doesn't quite actually equal 2, but it goes up to 2, and then everything less than that, going in that direction. If I have x is greater than 2, again I'm going to start right at 2 using a parenthesis to show that it doesn't actually equal 2. And now it's opening to the right because it goes everything to the right of 2, everything greater than that. And lastly, if I have x is greater than or equal to 2, again I'm going to use the bracket now to show that it can equal 2, going right to that line at 2, and opening to the right, showing that it goes everything to the right of 2. Another way we can represent these is with what is called interval notation. Interval notation takes the starting point and the ending point of the inequality solution and writes them as an interval. So x is greater than or equal to 2. Well, the smallest number x can be is 2, and it includes 2, so I use that bracket again, and then it goes all the way up to infinity. So I'm going to use my infinity symbol, which is an 8 on its side. And then since you can never reach infinity, infinity always has a parenthesis. So this is the interval notation for x is greater than or equal to 2. If I have x is greater than 2 without that or equal to sign, again it goes all the way down to 2 but not including 2, so I use a parenthesis, 2 again, smallest number, to the right. It goes all the way to infinity still, and use a parenthesis. So the only difference there, right, between or equal to or not or equal to, if I don't have that bar, I use a parenthesis. If I have it, I use the bracket. If I have x is less than 2, then again the lowest it is going is down to negative infinity, and it goes all the way up to 2 but not including 2, so we use a parenthesis. If I have that or equal to bar underneath, again it's still going all the way down to negative infinity, comes all the way up to 2 and includes 2, so I use the bracket. This is our interval notation. Let's go ahead and throw it all together now. If I have minus 8 plus 4x is less than or equal to 5x plus 3, I'm going to solve this, and then I'm going to graph my answer on a number line and write it in interval notation. So to solve this, we need to move our term to the same side. I usually move the smaller of the terms so that I end up with a positive coefficient for my x term. So here I have negative 8 is less than or equal to x plus 3. Then I subtract the 3 from both sides, and I have negative 11 is less than or equal to x. Another way to write this is to just flip everything around, and I can have x is greater than or equal to negative 11. So if I'm graphing x is greater than or equal to negative 11, right, it's going to be greater than negative 11, so to the right, has the or equal to, so it's a bracket, I open to the right, and I go everywhere to the right. If I'm writing it into interval notation, it looks a lot like what we see on our number line. Use a bracket down here to the smallest number, negative 11, and then it goes all the way up to positive infinity. So we have our interval notation here. Again, that bracket to show that includes the or equal to. Let's go ahead and solve this problem. We see if the ground temperature is 79 degrees Fahrenheit, then the temperature T above the Earth is given by the formula T equals 79 minus 19x, where x is the altitude in miles. Suppose that clouds form only where the temperature is 3 degrees or colder. Determine the heights that clouds form. So let's focus in on 3 degrees or colder. So the temperature can be 3 degrees or less than that. So temperature can be less than or equal to 3 degrees. Well, if the temperature is 79 minus 19x, let's plug that in for t, and we see 79 minus 19x can be less than or equal to 3 degrees. Now I can solve this and find at which heights the temperature is 3 degrees or colder. So I subtract 79 from both sides, and I have negative 19x is less than or equal to negative 76. I divide both sides by a negative 19, and when I divide by that negative number, my sign in the middle flips, and I have x is now greater than or equal to 4, and that is in miles. So we see anywhere at 4 miles or greater than 4 miles, clouds can form. Congratulations, we just finished chapter 2. If you have any questions, go back and look at this video again, or go and ask your questions in the discussion board. Another student or myself or both will be answering your questions. Also, don't forget the homework and quiz for chapter 2. Next week we will be taking a pre-test and a test over chapter 1 and chapter 2. So I will see you in 2 weeks for our next video. So next week, just review the 3 videos we've seen so far and ask whatever questions you have from the pre-test in the discussion board as well.